We know how to make black holes as the endpoint of stellar evolution. How does that work? Well, the sun, after another 5 billion years, has been around for 5 billion. So after a 10 billion year lifespan, it's going to run out of fuel in its core. And then it will release its outer layers of gas into space and lay bare a dense core that we call a white dwarf and create a very beautiful nebula in space, by the way. We'd be in the middle of it. We'll be long dead by then, but it would be a very beautiful nebula to other star systems if they train a telescope on us. That's one way a star can die, with the mass of the sun. But how about stars that are 8 or 10 times as massive as the sun? Well, they have a very different fate because much more is going on in the core of those stars than is going on in the core of our sun. Above a certain mass, the endpoint of a star is not just gently release the outer gases. The endpoint of that star is it runs out of fuel, its core collapses, and undergoes total spontaneous nuclear fusion, blowing the guts of the star to smithereens. It can outshine the entire galaxy in which that explosion takes place. We call these explosions supernovae. Typically, at the end of a supernova, what's in the core of that is a dense ball of neutrons. In keeping with astronomical naming and nomenclature, we call that a neutron star. Very dense, much denser than the white dwarf left over from when the sun dies. What happens if the star is 10, 11, 12, 15 times the mass of the sun? Well, it has so much mass that when the core collapses, it keeps collapsing. The collapse, in a way, is stronger than the explosion that would otherwise take place. It collapses in on itself, bada bang. Thus is born a black hole. That star would have lost some of its mass along the way, but what got folded into the black hole? 6, 7, 8, 9, 10 times the mass of the sun. We call those stellar mass black holes. And we expect them to be dotting the galaxy where stars had been born, laid out their lives, and died.